Hi, my name is George. I am an educational assistant for Math 050 at Delaware County Community College. The purpose of this video is to help you better understand math concepts covered in Module 2. If you have been struggling to understand the material and are having difficulty passing the practice test or even the post-test, my hope is that this video will help you. Before starting Module 2, you should already be proficient with addition, subtraction, multiplication, particularly the facts, and division. Here's a multiplication facts table you can use to brush up on your multiplication facts. Math competencies are skills that must be mastered. Competencies for Module 2 are listed below and are based on objectives from the e-text in MyLab Math. You must be skilled with these competencies to pass the Module 2 post-test. There are 3 skills that you must be proficient in to do well in Module 2. First, have the recall of the multiplication facts. Second, understand divisibility rules. Third, know the prime numbers. Divisibility rules are used to quickly determine if one number divides into another number evenly, that is, with no remainder. Use this chart to learn divisibility rules. A number is prime if it is greater than 1 and has only 2 factors, itself and 1. For example, 7 is a prime number because the only factors that multiply together to get 7 are 1 and 7. Number 1 is not prime. Numbers other than prime or 1 are called composite. I recommend that at a minimum, you should know the top row of prime numbers on this list. Even better, try to internalize prime numbers through the 40s. So, for example, my recommendation is to know these, because they're really going to help you out on the test. During the practice test, I will assume that you know multiplication facts, divisibility rules, and prime numbers. Let's quickly cover some properties of fractions listed in the e-text that you should know. The first property says that if you have a 0 in the numerator of a fraction, the answer is 0. The second property says if you have a 0 in the denominator of a fraction, the result is undefined or not defined. The next property says that if you have the number 1 in the denominator of a fraction, the answer is whatever the numerator is. The next property says that if you have the same number in the numerator and denominator of a fraction, the result is 1. And the last property we'll look at says that if you multiply any number a times 1, the answer is a, that same number. Now remember that 1 could be represented as some number over itself, and that's what they're saying here. We're going to see more of this when we're adding and subtracting fractions later on. Knowledge of these properties will help us solve some of the problems on the test. If needed, return to this video after learning all the competencies we reviewed. Be sure to write down the question number next to the problem you are working on. That way your professor can quickly find your written work. Also, you must show all intermediate steps when completing a problem to receive full credit. Use my own written work as a guide for the work you must show. So let's begin the practice test. Question 1. Find all factors of 75. So when they say all the factors, they mean the number 1, prime numbers, composite numbers, everything. So we have to list all the factors, all the numbers that multiply together that gives us 75. Now, there's no easy way to do this, but there is a systematic way to do it. And you have to have knowledge of divisibility rules to help you with this. So the best way to do it is to begin with the number 1. 1 times 75 is 75. So right off the bat, we have 2 factors, 1 and 75. Now, can we say 2? Can we say 2 times something is 75? Well, no, we cannot, because 75 is an odd number. So recall from the divisibility rules, if a number ends in an even number, 2 divides into it. So 2 is out of the question. How about the number 3? Can we say 3 times something is 75? Well, let's use the divisibility rules to help us. And for the number 3, we're going to add the digits. We're going to add the 7 and 5, and we get 12. And then we ask ourselves, can 3 divide into 12 evenly with no remainder? And the answer is yes. So if 3 divides into 12, 3 automatically divides into 75. So we know that 3 divides into 75. We just don't know how many times. Now, you can use long division to find out, or you can use coins, money coins, as a way for you to come up with some of these. 3 of what type of coins will give you 75 cents? 25, you said, correct. So 3 times 25 is 75. In fact, no even number, 4, 6, 8, will divide into an odd number. So we're going to skip all the even numbers. So let's jump over to 5. Can we say 5 times something equals 75? Again, divisibility rules tell us that if a number ends in 0 or 5, then 5 divides into that number. So yes, there is a number that we multiply 5 to get 75. What is that number? Well, this is not easy to see, right? So let's use long division to find that. So nothing too fancy here, quick and dirty, long division. 5 goes into 7 once, 1 times 5 is 5. Bring down the 5. 5 divides into 25 5 times. So there it is. 5 divides into 75 15 times, or 5 times 15 equals 75. All right, so for this course, for this test, you're going to have 8 or fewer factors. So right now we have 6 right here. Here they are. We have 6 factors. We could have 2 more. So we're going to skip 6. Can we say 7 times something is 75? Well, no, because right out of the multiplication table, we know that 7 times 11 is 77, not 75. Can we say 9 times something is 75? Again, it's in the multiplication table. 9 times 8 is 72. No. So this appears to be our list. So the way we're going to type in the computer is in numerical order with a comma between the answers. 1, 3, 5, comma 15, comma 25, comma 75. And you should always pay attention to the instructions over here. See how it says type a comma between the answers? So let's type that in there. 1, comma 3, comma 5, comma 15, comma 25, comma 75. Question 2, find prime factorization of 36. So here what we're expected to do is to find all the prime numbers that make up 36. And a good way to do this is to use what's called the factor tree. So you're going to write down the number here, 36 in our case. So this will be the base of the tree. And out of the base are going to come out branches of the tree, branches. And in these branches, what we're asking is, what number times what number equals 36? Now, there's no right or wrong with the factor tree. You could say 2 times 18, 6 times 6, 4 times 9. It doesn't matter, because in the end, after you get all the prime numbers figured out, it'll be the same thing. So it doesn't matter. So let's just say 4 times 9. 4 times 9 is 36. Now, you have to ask yourself, is 4 a prime number or a composite number? And it's a composite number, correct? Because 2 times 2 is 4. So when you get to a prime number, you want to circle it. Circle, circle. And then you ask the same question here. Is 9 a prime number? And no, it is not. Because 3 times 3 is 9. Circle your prime numbers. When you get to the point where all the branches have ends that are circled, which means they are prime numbers, then you are done. So the way we're going to write this down is start with the smallest prime number and put a multiplication dot in between. So 2.2.3.3. So if you were to multiply all this out, you'll get 36 back. Now, in MyLab Math, make sure you use the appropriate dot. So 2, and then you're going to use this dot right here, dot 2, dot 3, dot 3. Question 3, find the LCM of 27 and 63. Now, before we get to that particular question, I want to show you a problem that I made up using somewhat easier numbers, because I want to show you a couple of different techniques you can use. So one technique is called the one list of multiples. The other technique is called the factor tree. All right, so LCM means least common multiple. And what that is it's the smallest number that both of these numbers divide into. So a common mistake for students is to think that we're looking for the smallest number that divides into both of these, which is 2, but that's not the LCM. These two numbers have to divide into that bigger number. Okay, so keep that in mind. So let's try the one list of multiples technique first. And the way that works is that you look at the smaller of the two numbers, in this case 20. You look at 20, and then you ask yourself, can 20 divide into 30 evenly with no remainder? And the answer is no, it cannot. It cannot. So then what you do is you take the next multiple of the bigger number. So in other words, you say, well, how about 2 times 30? 2 times 30 is 60. And again, you ask the question, does the smaller of the two original numbers, the 20, does 20 divide into 60? And the answer is yes, it does. So 60 is the LCM. 60 is the LCM because 20 divides into 60 and 30 divides into 60. So 60 is the smallest number possible that both of these numbers divide into. So see how this number is bigger than these? It could be the same number. It could be the bigger of the two numbers. It could be. But in this case, 20 did not divide into 30. So we looked at the next multiple. We said 2 times 30 is 60, and we found it. Let's look at another way to find the LCM for this problem. So we're going to use the factor tree. We're going to break 20 down using the factor tree that we just used and the 30 down. Now, put a little divider in here so that way we don't get our two different trees mixed up. So 2 times 10 is 20. Circle your prime. 2 times 5 is 10. They're both prime. Here we got 3 times 10 prime and 2 times 5 prime prime. Okay, so the way we handle it here is that we write out LCM equals And then we're going to compare the left side to the right side. We're going to look at individual prime numbers. So let's start with the number 2. We have 2 2s on this side. On this side, we only have 1 2. So the side that has the most amount of 2s comes down. Since there are 2 2s here, these 2 2s come down with a multiplication dot in between. So the side with the most of a particular prime number come down. The loser stays back. So you never bring down numbers from both lists. Then we go on to the next number we haven't looked at yet, which is 5. There's 1 5 on this side, and there's 1 5 on that side. So here we have a tie. Whenever you have a tie, one side or the other comes down. It doesn't matter which one, but you never bring down numbers from both sides. If it's a tie, one side or the other. Now, we're not done yet because we looked at these, but we haven't looked at 3 yet. So we have 1 3 on this side, no 3s on that side. There are more 3s on this side, so this 3 comes down. After you look at and compare all the prime numbers, you multiply everything out. So 2 times 2 is 4. 3 times 5 is 15. And 4 times 15 is, in fact, 60. And we knew that already because we already found it right here. So which one do you use? It depends. It depends. If you can eyeball and see that the multiples are going to match within the first 2 or 3 multiples, then try the one list of multiples. It could be quicker. But sometimes if the numbers are fairly big and obscure, then the factor true technique is the way to go. All right, so I'm going to erase the board here, and we'll come back and do the original problem. Finding the LCM is very important for addition and subtraction of fractions. In fact, later on, if you get stuck on that step when we're doing those, come back to question 3 for a refresh on how to find the LCM. So question 3 here says, find the LCM between 27 and 63. So my question to you is, which do you think would be more appropriate? The one list of multiples or the factor tree technique? Well, I can tell you right now that if I take multiples of 63, it's going to get ugly quickly, right? That's a big number. That's not a very good number. It's gonna get ugly. So definitely use the factor tree here because it's going to be easier. So let's do that. So 27 and 63. Again, separate the 2 trees. 3 times 9 is 27. 3 times 3 is 9. Right out of the multiplication table, 7 times 9, 3 times 3. See how knowledge of multiplication facts and prime numbers is vital. All right, so let's figure out what the LCM is. So we're going to look on this side. Well, look, we have 3 3s. All the numbers on this side are 3s. We have 3 3s here. And we have 2 3s here. So recall that the side with the most comes down. Since there are more 3s here than there are there, these 3 3s come down with a multiplication dot in between. The winner comes down, the loser stays back. And then we look at the 7. 1 7 here, no 7s here. There are more 7s here. The 7 comes down. All right, now this is going to be a pretty big number here. And in fact, if you take a look, you can see that 3 times 3 times 3 is 27, right? There it is, 27. So we know that's 27 times 7. So let's scroll down a little bit and find out what the answer is. So 27 times 7. 7 times 7, 49. 7 times 2 is 14, and 4 is 18. So the LCM between 27 and 63, 427 and 63 is 189. This represents the smallest number that both of these divide into. All right, so when you're putting in the LCM in the answer box, this is what they want. They don't want prime factorization. So don't put that in there. Put the actual product, the answer, 189. Question 4, identify the numerator and the denominator. Well, this one's a pretty easy problem, right? So the top number is the numerator, and the bottom number of the fraction is the denominator, 14. Question 5, simplify 1326 over 0. Now, this was one of the properties that we looked at before. And whenever you have a 0 in the denominator, the answer is undefined. Undefined, not defined. So it's going to be B for this problem here. Question 6, simplify 0 over 4. This is another property that we looked at. And whenever you have a 0 for the numerator in a fraction, the result itself is 0. So we're going to type in 0 into A right here. 0. Question 7, multiply 2/3 times 5/7. When you multiply fractions, you multiply straight across. So you multiply the two numerators and also the two denominators, and then you get the answer. Now, what I would recommend is to see if you can reduce before you multiply, because you always must have a reduced simplified answer. And it's sometimes, most of the time, it's easier to do it up front here before you multiply than it is to have a big number at the end. And the way we reduce up front is we look up and down to see, is there a number that divides into both 2 and 3 to make it smaller? 1 divides into both, but it doesn't make it smaller. So 1 doesn't help. So no, that does not reduce. Then you look at the next fraction up and down. Does that reduce? No. However, you also look diagonally to see if you can reduce. Is there a number that divides into 3 and 5? Nope. Finally, you look this way diagonally. Can 2 and 7 reduce? No. So to reduce before you multiply, you look up and down and diagonally. You do not reduce side to side. You only multiply side to side. Now that we looked and saw that we cannot reduce, all we got to do is simply just multiply straight across. So we have 2 times 5 is 10. 3 times 7 is 21. Now, without even thinking about it, we know this is our final simplified answer. And the reason we know that is because we could not reduce here. If we could not reduce here, then we can definitely not reduce here. So our answer is 10 over 21. Question 8, simplify or reduce 4 over 12. There's a couple of ways you can do these kinds of problems, and I'll show you the first way now. What you want to do is you want to think, this is a thought bubble here. This is what you're thinking about. You want to think of the biggest number that you can think of that divides into the numerator and the denominator. So what is the biggest number you can think of that divides into 4 and 12? If you said 2, it would not be correct. 2 does divide into both, but it's not the biggest number. We want the biggest number to get the maximal reduction. So the biggest number that divides into both of these is the actual number 4. So then what we're going to do is say, okay, the 4 that I'm thinking about will divide into this 4 one time. The 4 that I'm thinking about will divide into the 12 3 times. Now let's cross out the thought bubble so we don't get confused and just simply write down what is left over. We have 1 over 3. There it is. So 4 twelfths reduces to 1/3. Now let's try it in a different way. Let's try it this way. So 4 over 12. Another way to do this is to break these numbers down into their prime numbers. So 2 times 2 is 4. 2 times 6 is 12. So 2 times 6 is 12. But 6 is the same as 2 times 3. Okay, so we broke these numbers down into their prime numbers. 2 times 2 is 4. 2 times 2 times 3 is 12. Now that we did that, we can look and see that, oh, wait, we have the same number on top and bottom. And recall from that property that we looked at the beginning of the video, whenever you have 2 numbers over each other, it's 1. Because 2 divided by 2 is 1. Same thing here. So these cancel out. So what do we have left? Now, we have a blank here. So what are we going to put? Well, definitely don't leave it blank. So technically, this is the same as this, isn't it? Isn't 1 times 4 4? Yeah. So there's your 1. Put a 1 there. Never leave the numerator blank. And then there's your 3. And look, there it is. We already have it right there. So you should be comfortable in reducing using both techniques. So our answer is 1/3. Question 9, multiply and simplify. So we have 3/5 times 35. So we have a fraction times a whole number. So the best way to handle this is to change the whole number into a fraction. And the way we're going to do that is to use the property that we looked at earlier at the beginning of the video. So let's rewrite this. So we have 3/5 times. Now recall in the property that we said we can put a 1 underneath any number and it doesn't change that number. So we're going to make this 35 as 35 over 1 because a fraction means division, correct? 35 divided by 1 is 35. So we didn't change this. We just made it easier for ourselves to solve this problem. So now we have a fraction times a fraction, and we know how to handle that like we did in the last problem. So again, we have to decide, do we want to multiply across and then reduce a big number? Because look, they said simplify. In fact, even if you didn't, always simplify, always reduce a fraction. Or should we look to see if we can reduce before we multiply? We should do that. So let's go ahead and try it out. Let's look up and down here first. Can this reduce? No. Cannot reduce. Well, I mean, yeah, I can go back to here, but that's not going to help us, right? We're going backwards. So the 1 will not get any smaller. You cannot get smaller than 1. So no, this will not reduce and remain as a fraction. So up and down, we cannot reduce. Well, let's look diagonally. And again, because we have a 1 involved, we cannot make the 1 any smaller, so the 3 and 1 does not reduce. Finally, let's look this way diagonally. Cannot reduce. Is there a number you can think of right out of the multiplication table that will divide into 35 and 5? Don't say 7, because 7 cannot divide into 5. We'll see 7 in a minute. So the number that divides into both 35 and 5 is 5. 5 that you're thinking about divides into 35 7 times. See, here's your 7 right here. Now, whenever you reduce, you always reduce 2 numbers. Some students just reduce 1 and forget about it. No, numerator and denominator both have to come down. So don't forget this one, right? 5 that you're thinking about divides into 5 1 time. Cross out the thought bubble. We don't need it anymore. Now, we look again real quick to see if we can reduce, but nope, nothing reduces. Let's multiply across and see what we get. 3 times 7 is 21. 1 times 1 is 1. Now, whenever you have a 1 in the denominator of an answer, don't leave it there, because remember, this could be reduced. 21 divided by 1 is 21. So 21 is our answer. The reason we put a 1 underneath the 35 here was to multiply and make it easier for us. But for the answer, don't leave a 1 underneath. Just get rid of it and use the numerator as your answer. So our answer is 21. Question 10. Multiply and simplify. 11 over 14 times 2/3. So again, we're not going to multiply across until we make sure this is fully reduced before we multiply. So we look over here, up and down. Will that reduce? Nope. Will that reduce? Nope. And then diagonally, will this reduce? No, it cannot. Diagonally, can this reduce? Yes, it can. So what number can divide into both the 2 and the 14? That number is 2. The 2 that you're thinking about divides into this 2 1 time. The 2 that you're thinking about divides into 14 7 times. Let's cross out the thought bubble so we don't get confused. And then we'll take another quick peek and see, can we reduce further? 11 and 7, no. 1 and 3, no. 1 and 7, no. 11 and 3, no. See, now we're confident that our answer is fully reduced. So 11 times 1 is 11. 7 times 3 is 21. Right there. Now, let me just show you the other alternative way to do this. So we have 11 over 14 times 2/3. Now, one thing to remember is that this multiplication dot you see here, this is really like a bridge between these fractions. You can think of this multiplication dot as connecting these two fractions. So whether these fractions are together or apart like that, as long as there's a multiplication dot, you can think of them as being together. So let's do that. Let's put the 11 here. Let's put the times 2 here. Now, let's go ahead and break this down into the prime numbers. So what times what is 14? Well, 2 times 7 is 14. And then we also have times 3 right here. So all we did was we put these together. We broke the 14 down into 2 times 7 and brought the 3 here and basically connected these fractions, because we can do that if you have a multiplication dot. See, now we have the same number top and bottom. And they don't have to be directly over each other. It doesn't matter. As long as there's a multiplication dot in between, this number could be way down here. It doesn't matter. So we have 2 divided by 2 is 1. So these become just 1 or cancel out. Does anything cancel out? No. So what is left over? 11. 7 times 3 is 21. And there it is. We already knew that. So you can use this technique here or this technique to multiply or reduce. So let's type in 11 over 21. Question 11. 8/3 divided by 8/7. Division of fractions is very similar to multiplications of fractions. The only difference is that we have to do a step in the front at the beginning of the problem. We want to change division to multiplication and then solve the problem as multiplication. The way we're going to do that is do what's called keep, change, flip. Okay, so keep that in mind. So we're going to keep the left fraction the way it is. We're not going to change it. Keep it the way it is. We're going to change division to multiplication. And then finally, we're going to flip. We're going to flip the right fraction. Keep the left fraction, change division to multiplication, flip the right fraction, and let's do that down here. So 8/3, change division to multiplication, and then you're going to flip, do the reciprocal of this. So this becomes 7/8. So we changed division to multiplication. So from here on out, it's going to be the same process as if we're multiplying, because in fact we are multiplying. And as before, let's see if we can reduce before we multiply. We look up and down. Can we reduce this? No. This way? No. Diagonally? No. How about this way? Yes, we can. Now, you always want to pick the biggest number that divides into both of these. You could say 2, and it will reduce with 2, but it will not be the biggest number, which means you'll have to reduce again later. You could pick 4. Again, it's not the biggest number. So what is the biggest number that divides in the 8 and 8? Well, that is the number 8 itself, right? Number 8. So the 8 that you're thinking about will divide into this 8 one time. The 8 that you're thinking about divides into this 8 one time. Cross out the thought bubble so we don't get confused. And then look and see, can anything else reduce? Does not look like it, does it? So now let's multiply what's left over. 1 times 7, 7. 3 times 1 is 3. And there it is. The answer is 7/3. Now, one quick word of caution here. If it was possible to reduce in division, do not do it. You cannot reduce up front while in division mode. You have to wait until you're in multiplication mode to reduce. Now, here we couldn't reduce anyway, because remember, you cannot reduce side to side anyway, right? But if you could, you still could not do it. Not in division mode. Change division to multiplication, and then you can reduce up front. I've seen this happen as a mistake. So let's type this in, 7/3. Question 12, 8 divided by 8/7. So here we have a whole number, and here we have a fraction. So the best way to handle this is to change the whole number into a fraction. And we're going to put a 1 underneath it, so that way we can do this problem. So we're going to change the 8 as 8 over 1 divided by 8/7. We just did a problem where we divided two fractions, so now we know how to handle that. Again, we're going to do keep, we're going to do change, and we're going to do flip. We're going to keep the left fraction, change division to multiplication, flip the fraction for this side here. So let's do that a little bit further down. So 8 over 1 remains the same. Change division to multiplication. Flip this upside down. This becomes 7/8. So now we have a multiplication problem. We're going to reduce before we multiply across like we did before. And in fact, we just found this out, didn't we, in the last problem? What's the biggest number that divides an 8 and 8? 8. 8 divides an 8 one time. 8 divides an 8 one time. So the 8's cancel out. Cross out the thought bubble. Multiply what's left over. We have 1 times 7 is 7. 1 times 1 is 1. But remember, if you have a 1 on the bottom in the answer, don't put it there because it's not fully reduced. So this is our answer right here, 7. Question 13. 2/3 plus 5/6. So here we are adding two fractions, and we have two different denominators. Whenever you have two different denominators and you're adding or subtracting fractions, you got to perform these 4 steps right here. So step number 1 is to find the LCM of the two denominators, which is really the LCD. Step 2, multiply fractions by some number. We'll do this in a minute to match denominators. Step 3, add or subtract, depending on the problem, numerators only, but keep denominators. And then step 4, reduce your final answer if you can. Now, LCM, I talked about it in question 3. So if you're a little bit uneasy about how to find that, go ahead and go back to question 3 and look at that explanation. So here, I'm assuming you know how to find the LCM fairly quickly. All right, so that's step number 1. So let's see if we can find out what it is. Step number 1, LCM. So we have 3 and 6. So what's the smallest number that both of these divide into? Let's use the one list of multiples technique. Can 3 divide into 6? Yeah. So therefore, 6 is the LCM. Because 3 divides into 6, and 6 divides into 6. Now, I'm using LCM, but remember, it could be LCD. It's the same thing. D means denominator. LCM, LCD, it's the same thing. So it's either one will work. Step number 2. Now, we're going to use our knowledge of the LCD to change this fraction to get the same denominators. That's what we're looking to do here. We need to make both denominators have the LCD. So how are we going to do that? Well, we got to do something to this fraction. So step 2, rewrite this with a little space in front. 2/3 plus 5/6. The reason you're going to put a little space in front is because then you're going to put a multiplication dot in front of the denominator and ask yourself, what number times 3 will give me 6? That number is 2. 2. 2 times 3 is 6. Now, you cannot change the denominator or the numerator of a fraction and not change the other part. So if we change this by multiplying by 2, we got to do the same thing to the top to keep the same ratio so we don't change the value of the fraction. So We're going to multiply the denominator by 2 and also the numerator. This fraction, though, has the LCD already there, so we don't need to multiply by anything. We're going to leave this the way it is. So step 3, let's simplify. 2 times 2 is 4. And we know that 2 times 3 is 6. Bring this part down. See, now we have the same denominator, so we can just simply add the numerators. Let's do that over here. 4 plus 5 is 9 over 6. Step 4, reduce if you can. We have 9 over 6. 9 over 6. So let's reduce this. So let's use the factor technique. 3 times 3 is 9. 2 times 3 is 6. 2 times 3 is 6. 3 over 3 cancels out. And what do we have left over? 3 over 2. 3 over 2. That's our answer. Okay, so find the LCM, multiply by some number over some number. See, it has to be the same number over itself to get the same denominator. Add or subtract, whatever it is. If you can, reduce. So our answer is 3 over 2. Question 14. Add 7/9 plus 5 over 6. So again, here we have different denominators, so we got to perform the 4-step process. So step number 1, we're going to find the LCD or LCM. Let's call it D this time. Let's use the one list of multiples technique. Can the smaller number divide into the bigger number evenly with no remainder? No. Take the next multiple of the bigger number. 2 times 9 is 18. Can 6 divide into 18 evenly with no remainder? Yeah. So 18 represents the smallest number that both of these will divide into. There it is. We have our LCD. So go to question 3, where I discuss LCM in more detail if you're still having trouble with the LCM. All right, step 2. Now notice that neither of the fractions has the LCD, so we have to multiply both by some number to change these numbers to become 18. So when you rewrite these fractions, leave space in front. So 7/9, leave some space in the front, plus 5 over 6. The reason we're leaving space in the front is because then we can multiply. Put a multiplication dot in front of the denominator here and ask yourself, what number times 9 is 18? Well, that is 2. If the bottom number is going to be 2, the top number has to be the same, so we don't mess up the ratio of the fraction, the value. Okay, so we'll do the same thing to this fraction. Put a multiplication dot. Ask yourself, what times 6 is 18? And that would be 3. If the bottom number is 3, the top number has to be 3. Now, sometimes I get asked this question, how come these numbers are not the same and they're different? That's a very good question, and the answer is simple. The reason is because these numbers are different. That's why. See that? Now, up and down, they're going to be the same here and here, and that's so we don't mess up the ratio of the fraction. But side to side, they're going to be different. That's because the original denominators are different. Okay, so don't let that confuse you. So step 3. 2 times 7 is 14. Without thinking about it, we know the denominator is 18. 3 times 5 is 15. We know the denominator is 18. Add numerators. 14 and 15 is 29. And if you don't know that, you can do that work on the side. Keep the denominator. Step 4 says reduce if possible. Now, here's a good example where knowing your prime numbers can help out. 29 is a prime number. It will not break down. So, therefore, it will not reduce. So this will be our answer right here. 29 over 18. 29 over 18. Question 15. 8/9 minus 7/18. So now we're doing subtraction. But you know what, though? It's still the same 4 steps. The only difference is in step 3, we're going to subtract rather than add. Everything else will be the same. So our first step is to find the LCM or LCD. LCD. Between 9 and 18. Can you figure that out? Well, let's use the one list of multiples technique. Can the smaller number divide into the big number evenly with no remainder? Yeah. So the bigger number then is the LCD. Because 9 divides in 18 and 18 divides in 18. So now in step 2, we got to multiply the left fraction by something to make the denominator become 18. So leave some space in the front. 8/9 minus 7/18. This is going to stay the same because the denominator is the LCD, so we don't have to do anything with it. We got to put a multiplication dot in the denominator and ask ourselves, what times 9 is 18? And that would be 2. If the denominator is 2, the numerator has to be the same. So step 3. 2 times 8 is 16. And we know the denominator is 18. 7 over 18, that stays the same. So now we subtract numerators. 16 minus 7, well, that's 9 over 18. And then finally, we look and see, can we reduce 9 over 18? Can 9 over 18 be reduced? What's the biggest number you can think of that divides into 9 and 18? Yeah, 3 will get you there. It's not the biggest, though. 9 is the biggest. 9. 9 that you're thinking about divides into this 9 once. 9 divides into 18 2 times. Cross out the thought bubble. What do we have left? 1 over 2. 1 over 2. So that's what you want to type in is the reduced simplified answer. Question 16. 1/3 minus 1/8. So again, we'll use this 4-step process to help us solve this problem. So step number 1 is to find the LCD. And again, these numbers are fairly small. Let's use the one list of multiples. So, can 3 divide into 8 evenly with no remainder? No. Take the next multiple of the bigger number. 2 times 8 is 16. Can 3 divide into 16? No. Take the next multiple of the bigger number. 3 times 8 is 24. Can 3 divide in 24? Yes, it can. Okay, so the LCD is 24 because 3 and 8 both divide into 24. Now, step 2 here, we got to change both denominators. So we got to leave space up front for both fractions. 1/3 minus 1/8. Put a multiplication dot here and ask ourselves, what number times 3 is 24? Right out of the multiplication table, 8. If the bottom number is 8, so is the top. We do the same thing on this fraction, multiplication dot in the denominator, and ask, what times 8 is 24? Well, here it is, right here, 3. So if that's 3, that's going to be 3. All right, now that we're set up, let's go ahead and simplify this, multiply it out. So we have 8 over 24, 8 over 24 minus 3 over 24. Okay, we have the same denominator. Step 3, let's subtract numerators. 8 minus 3 is 5 over 24. Then step 4 says, reduce if possible. So we have 5 over 24. Is there a number that divides evenly to both to reduce these? No. And that's our final answer right here. So 5 over 24 is our reduced answer. Question 17. Convert a mixed number to a fraction notation. So the way we're going to do that is we're going to multiply the whole number times the denominator and then add the numerator to get our new numerator. So this is the whole number part, and this is the fraction part. So we're going to multiply these two. 1 times 100 is 100. Then we're going to add the numerator to that to get us our new numerator. So 1 times 100 is 100. 100 plus 57 is 157. And then we keep the denominator the way it is. All right, and that's it. So multiply whole number with denominator. Whatever answer you get, you add the numerator to it, and all of that becomes the new numerator. And then simply keep your denominator the same. So our answer is going to be 157 over 100. Question 18, and our last question. Convert a fraction into a mixed number. So now we're going the other way from our last problem. So the way you want to handle this problem here is to change fraction notation into long division. Now, the 69 represents the dividend. We're dividing into the 69, which means this goes inside the box. Inside the box. 10 is the divisor. We're dividing by it, so 10 goes outside the box. So you have to convert a fraction into long division and make sure you put the numbers where they belong. So now we're going to do just a one-step division problem. 10 divides into 69 6 times. 6 times 10 is 60. Subtract. And our remainder is 9. And you want to stop right here. Now let's label some of these numbers. So this number here, 10, is the divisor, D. 6 is the quotient, Q. 9 is the remainder, R. The reason I'm showing you this is because sometimes it helps if you internalize this. Q, R, D. So this is a template of where these numbers are going to go. Okay, so this is the mixed number format. Q, quotient, R, remainder, D, divisor. All we got to do now is simply just find the numbers and then put them in that spot. Let's look for Q first. Q is the quotient 6. R is a remainder, 9. It's going to be the numerator here. D, divisor, 10. It's going to be the denominator. So just recall, put this in your mind, QRD. And then you have your answer right here. This is the mixed number format of the fraction. So let's type that in. And let's use the appropriate mixed number entry box. 6 and 9 over 10. All right, so let's see how we did on this practice test. Okay, very good. As you saw from the practice test, it is assumed that you possess the foundational knowledge of multiplication facts, divisibility rules, and prime numbers, which are used in many of the problems. Competencies such as finding all factors of a number, prime factorization, determining the least common multiple, reducing, multiplying, dividing, adding, subtracting, and mixed number conversions are merely procedural that you must do in steps. Make sure you know the difference between finding all factors of a number and prime factorization, because it is a common mistake for students to confuse these two competencies. Finally, remember to do these two items. 1, write down the question number next to the problem you are working on. 2, show all steps in your written work. To do well on your post-test, you must be able to pass the practice test without using notes, without using a calculator, without any help, and without referencing this video as you are taking the practice test. If you still have questions about a math concept, ask your instructor or an educational assistant for further explanation. That completes our walkthrough review of the Module 2 practice test. Thanks for watching. Now it's your turn.